So right now we are waiting for the organizer to get the session started.
So this is a bit, the timing of this session is a bit difficult for people on the West Coast. So we will lose a few potential participants.
6 in the morning there, I guess.
Yeah. And as much as they would love to listen to us, I doubt they will wake up for it.
I'm going to replenish my coffee.
Alina, just before you join, we just talked about that everyone have 15 minutes to present, and around 12 minutes, I will put like a sum up sign here. That's just a reminder.
All right, sounds good. Thank you. You can also, at least when I speak, feel free to say something. I'm okay with that.
Okay, thank you.
Actually, I probably would appreciate it more than some sign somewhere that I would probably miss.
So I think it's all now, and let's trying to meet the people. Good morning, everyone, and welcome to our session on the collaborative problem solving. And we want to thank our organizers of NCME to create such an opportunity for us to exchange some interesting ideas during this unusual time. So collaborative problem solving is a very important 21st century skill, and but it's extremely difficult to measure and assessing that. And there's a lot of effort in the community over the last 10 to 15 years. And today we organize a coordinated session to include several of these pioneers in different large-scale assessment of collaborative problem solving to give everyone an update of the current status. And we hope by the end of this presentation, you will know roughly where we are now, and you may have ideas about where we should go in the future. So because we have 5 presentations and a discussion within this 1.5 hours, so I'm not going to waste more time. Let's switch to our first presentation, Esther Carey from this, she worked with this, is one of the major player of ATC 21st. Thank you, Esther. Now I give the share to you.
Thank you, Zhanggang. Okay, good morning. I think it's good morning. What I'm going to talk about is exactly what you can see there. It's about learning from the past. And rather than talk about all the things that we achieved in this project, I want to talk about the things that needed improvement. And that's not to detract from the achievements that were in place, but it really is about trying to share some of the lessons learned so that we can move on. So the assessment and teaching of 21st century skills, I'm just trying to move on my slide. There we go. Was an initiative of many different parts. It drew from and on researchers, on academics, and on technology experts, and not so much on the teaching fraternity in education, and not really looking so much at application. The achievements were several. First, there were some really great framework documents put together in the early days. And they included contributions by Marilyn Binkley and others on what they called the CASAVI framework: knowledge, skills, attitudes, values, and ethics. very much the same sorts of things that we're hearing about a great deal these days when countries are adopting much more broad 21st century skills or transversal competency frameworks. So that was one achievement. The second was pulling together different frameworks, different theoretical frameworks for two skills in particular, one being collaborative problem solving and the other being digital literacy. And a lot of the work that was done in terms of developing those theoretical frameworks was based, particularly for CPS, on the work of O'Neill a few decades earlier. And those theoretical frameworks for CPS in particular had quite a bearing on where OECD's PISA construct went to and came from. And then the third achievement was really the mounting of person-to-person tasks on online collaborative platforms. And it's those particular set of outputs that I'm going to talk about today. It's less, as I said, about the achievements and more about the actual issues. So very quickly first, this was the theoretical structure that we put together in the first instance. And this came about from getting a large group of academics together from slightly different areas of psychology and education to build this, so that we had the overarching complex skill of collaborative problem solving. We then had these two components of the cognitive and social, and then we identified dimensions within each of those components. So this was purely theoretical. It was informed by, as I said before, a lot of the work of O'Neill, but we had no evidence at this point. And so then if you look at the model a little bit more, you'll see here that we had a number of what we called elements within each of the dimensions. So you can see in the first one here under participation, you've got action, interaction, and task completion, and so on. So as you can see there are a lot of elements. There are about 20 elements across the two major components. So for a robust assessment, what that meant is that we would need a huge number of data points. And therefore, we'd also need either a great many tasks, or we'd need a great many rich tasks that would be able to provide the opportunity to generate that many data points. And so that is the first of several issues that came back to bite us. So, of course, we needed to develop tasks that would provide the utility of differentiating skill levels. So the goal was for us to put together tasks that would generate data across those elements, those 20 or so elements, by different degrees of difficulty or expertise. And so what you can see on this screen is just one example of a dimension, social regulation. And you can see the elements within it: negotiation, knowledge of self, knowledge of others, responsibility. And then in the second column, what you've got there is a very brief description of what those are, and then some very fuzzy ways of trying to say, what might this look like at a low, a middle, and a high level of competency? And these particular identifications were to help the task developers think, how can we start looking at the way we design the task for the online platform. So here we have another issue, not only of the fact that we needed more data points, but there was an assumption that the stability of the difficulty level of items would be there. In other words, that any individual item would always present the same difficulty level. And I'm going to come back to this particular issue. Just as an aside, in this example under the social regulation, behaviours across those difficulty levels in some cases could be inferred from what we call the chat action sequencing. And I'll come back to that. So here's just a couple of images. The first image up in the top left-hand corner is just sort of the portal that students came into when they would start to come in to the online platform to take the tasks. Then there's a couple of images here from a task that was called the oil task or something like that, olive oil. And it's basically a Tower of Hanoi type task. Over on the right-hand side of the screen, you can see some of the computer speak that comes out of students being able to move particular artifacts around in a problem space. So a number of different complex tasks were developed for the collaborative online completion by the pairs of students. And a majority of those tasks, and this is another issue I'll come back to, were drawn from pre-existing tasks. And what we did was we manipulated those in different ways to optimize the opportunity for collaboration. So that was another issue for us. We developed the tasks from others, not from scratch. So if we developed tasks from scratch, maybe we could have enabled them to capture more of both all the elements as well as the levels of difficulty across those not elephants. So in most of the tasks, it's all mouse, drag and drop. So here we have a screen of a little bit of an output of a pair of students. So we've got student A and student B. So if you look down that first column of the text there, and you can see where students take particular actions. For example, they move some amount of oil from one receptacle to another. They get some system speak that actually feeds back to the student what's happened. And then you can also see in part of it that you can see chat. So here we've got chat where the child says lol. Here's student A saying, I read the instructions, and B saying, I did. I know what to do, what, put oil and so on. So what you have is the sequence of the chat and the sequence of the actions being followed here. So we log both the processes and the chat. Some actions can be taken only by student A, and some actions can only be taken by student B. And the chat, of course, helps the students to work out which things they want to do first. So it's a very natural interactive sequence. It's very natural, but it presents an analytic challenge and an imbalance. You think about it a little bit like a tennis match. You receive the ball at a certain level of difficulty, you respond with a certain level of quality that in turn is received at the other end again at another level of difficulty. So we've got a dependence in terms of the performance of the two students on what looks like the same action, but it's actually experienced at different levels of difficulty. So that's another problem for us. I think that's all I want to say on that screen. So we have several issues here. We have this one around the dependence, which I just described, that how I respond is going to be a response to what somebody else does. And depending on the quality of that response that was given to me, my performance is going to vary. And so not only is that a sort of a seminal difficulty, of course, in terms of actual analysis of the data, that's another major issue. The second point here is around the unequal actions, because each student has access only to some actions, not all actions. And there was no a priori working out of whether those different actions actually, again, were equal in difficulty or not. So, and the third part of that is that the number of actions that are implemented by students will be different, because the students, although there are only set types of actions they can do those actions many times. So they can iterate many times, which of course is part of collaborative problem solving. You know, you want to allow people to go back and forth and experiment, but that also means that when you're scoring those iterations, you need to be thinking about which one are you scoring? Are you going to score them in terms of frequencies and so on? The third dot point there is this restriction in the task design, that we didn't, I think in retrospect, we didn't have sufficient tasks. I think we had maybe about 12 or 13 complex tasks. And if you think back again to those 20 elements you want to sample, 5 different dimensions, 2 different components, and if you think about the fact that you want to sample those at different levels of difficulty, you would have to do a huge amount of tasks to be able to generate that amount of data. And of course, the outcome of that was that we didn't get as clean dimensionality in our analyses as we would have liked. And then the final point here is the one around this of the convenience of having tasks that we picked up and manipulated, changed, added features to, rather than constructing tasks from the bottom that were constructed in accordance with the theoretical model. So instead of that, we had our theoretical model. We then said, oh, this particular problem looks like a decent one. We can manipulate that in a way that we can capture some of these elements. You know, in retrospect, it was fairly, not world breaking, but it was pretty good stuff at the time. But when you look back at it now, you think, well, if we knew after 3 years if we knew at the beginning what we knew at the end of that 3 years, then there are so many different things that we would have done and could have done and should have done. So where does that leave me now? I don't work so much now in this sort of itty-gritty technical area. But my concerns, particularly because I'm working much more in the aid and development sector, and I'm working with many countries that are introducing 21st century skills into their curricula, into their pedagogy, and into their assessments, I'm very concerned about how do we establish criterion validity of when we have tasks, whether they're technologically based or in the classroom, how do we know that that actually implies that students have the capacities that we believe we're actually assessing for? And so we've done a little bit of work comparing online responses of students with their classroom engagement in exactly the same tasks. And we found that incredibly challenging and difficult. And that's partly, of course, because of this issue of how do you capture data? It's one thing to capture it in the computing and capturing it behind the scenes, but when you've got a teacher with 30 or 40 or more students in a class, how can that teacher possibly audit or monitor what's going on? And the other work here done by some colleagues of ours in Finland was starting to look at a lot more of the qualitative aspects of what was going on and thinking about what do we actually value when we're looking at collaborative problem solving? Do we value the endpoint or do we value the process? And for me, it's very clear that we value the process. Anyway, I hope that gives you an idea of where we were back in 2010 to 2013. And I'm really looking very much forward to hearing about where we've moved. Thank you.
Thank you, Esther. It's great. We have one presenter, Alina, had another meeting. So she would like to present earlier. So Art, is that okay? We have Alina to present after Esther, and you go the third one.
I think Art is muted.
Okay, so I will assume that Art kindly agree. So,
Art, you are muted.
I'm trying to get out. I started to launch my presentation and I don't know what to do to get out of that. So why have I released my share screen or not?
I think Alina can directly share.
Okay, can you try directly sharing it?
Yes, I can. And
okay, there we go.
Thank you all
Yeah.
for being flexible. So my presentation today is a bit pivoted from what I submitted last spring or whenever we submitted. So I will talk about collaborative learning methods and design today. And the outline of my presentation is to talk about primarily about methodologies. I will review a few recent methodologies for measuring learning in collaborative environments, such as games, simulations, intelligent tutoring systems. And in that context, I will refer to the Bayesian knowledge tracing that has been developed in the educational data mining community for individual learning. And similarly, the additive factor model, which is also a model for learning, but both of them can be applied to the team level. And this is what I will talk about today. I will also discuss about how to extend these two methodologies and how to talk about collective intelligence from a statistical perspective. Then I will talk about a framework that my colleagues and I introduced. It's called the Competency Architecture for Learning in Teams that we call CALM. And then I will give an example from the Duolingo learning app of a particular challenge. It's called Duolingo Collaborative XP. And it's really a relatively small MVP that the team tries, and it's a first step towards accountability and collaboration. So, and I will talk about this framework and how the CALM framework and how this would refer to Duolingo, to the Duolingo example. So when I started working on collaborative problem solving, Peter Halpin and I thought that from a statistical perspective, the degree of interdependence between the participants, that in our case, the two participants, can be expressed statistically and can become the basis for an engagement index, which in turn can help build measurement models for collaboration. So that was the main idea that we had in 2012. Well, and at that time, we were looking at different aspects of collaborative teams that differ in terms of the degree of interdependence. For example, in an ensemble, you really need a strict coordination and rich interdependence, such as a music ensemble, a soccer team. In a group, there is little interdependence. For example, gymnastic teams. They are somehow a team, but each of them has different strengths and they do their own things. And then you have synchronized individuals that operate more or less in isolation on a shared timeline. For example, in a multiplayer video game, you need to defend a castle. That could be the collaborative task, and you think you collaborate with the others, but actually they operate in complete isolation. So if we look at this degree of interdependence and this taxonomy based on interdependence, then we can think about what it means to have learning models for individuals and teams also from that perspective. The models that have been used in the past for learning track and predict individuals' knowledge from the observed performance. And the knowledge is often described as a partition of attributes that the learner needs to master. Now, think about if we apply the same mental framework, conceptual framework to a team, then we can also describe the team performance as mastering attributes that are relevant for successful team learning, sharing information, negotiating, supporting the team members, and so on. So let's see how that will translate if we look at the Bayesian knowledge tracing, which is a well-known learning model for individuals. So it's an approach to modeling the process of students' knowledge acquisition, and it tracks changes in the mastery of the latent student abilities from the observed performance. So I'm sorry on this early morning to give you some formulas here, and actually quite a heavy slide, but actually the idea is relatively simple. On the left side on the picture, you have different observations. That's what we get to see from each student over time. And then you have above the states that are latent that we think are well reflected in what we see. So we have different probabilities, the emission and the transition from a state to another. And the emission is the probability that actually the true state is well reflected in the observed. And then you have the timeline going forward. So on the right side in the tables, you have how we describe these probabilities, with the mastery and the unmastering probability being the ones we are mostly interested in. And you can see that we have the specific definitions for success and failure that depend on all these probabilities, including probability that the skill was mastered, the probability of learning the skills after an opportunity was actually displayed, probability of a careless slip on an actually mastered skill, and the probability of a lucky guess on an unknown skills. Now, not all the models and adaptations of the BKT must have all of these probabilities. There are a lot of papers of variation of BKT. Now, to continue with formulas, the main idea, I won't stay too long here, but I just want you to take a look at how this could translate for teams. So again, if you think that if the theory of collective intelligence is well defined, and if we express the mastery of team performance or of team collaboration, and we explicate that by attributes, then we can conceive elements of learning for the team as a whole, as opposed to each individual. So you can, if you are very familiar with the formulas for the BKT, you will see that we change these probabilities to refer to the evidence of mastery given the evidence at the time t for the team performance. Now, similarly, with the additive factor models, they have been developed by Olsen, Alivan, and Rummel, and some of these methods are also attempts to evaluate whether a student whether a student performed well after a learning opportunity. So what we also did was to expand on this work and apply the same philosophy that there is a collective intelligence. And if that's the case, what are the attributes that explain the learning that needs to take place? So that's what I just said. So I will move forward, and these are the formulas that will again explicate how these models would adapt for teams. So the most important part there is that you have a group that is a collaborative condition C that will appear in many of these formulas. So what does it mean for a real life example? And I'm relatively new at Duolingo, so this is really a superficial presentation of this example. But I was looking to see if there is anything that my colleagues have been doing that would match this type of work. And I was delighted to find out that in the learning app, Duolingo is always looking for ways to improve learning, make students spend more time learning, and they always test different opportunities for learning. And one of them is what is called Duolingo Collaborative XP, which has been an MVP that has been tried out over the past few weeks or so. Now, what is the Duolingo? Many of you, of course, are familiar with it. It's the learning app primarily, and you can study many languages. And it's free, which I would say is the most important piece of this activity. It's free, it's fun, it's accessible, it's gamified, and it's engaging. However, for the most part, is a solitary endeavor. So you learn by yourself whenever you want, wherever you want, as long as you have internet. And actually, even there are some opportunities for offline learning. the team works continuously and really hard. I'm so impressed with the attitude and with the way they think about how to improve the product all the time. And they do a lot of experiments. So everything at Duolingo is database. Experiments and MVPs, and all features are A/B tested, which is of course also easy once you have million and million of test takers. So it's, you know, in a few hours you get your samples for pretty much everything you've been dreaming of. For many of us, this is like you know, the paradise, as you may imagine. So what is the collaborative XP? So as I said before, the motive is for increasing the motivation. It's really hard to stay motivated for language learning, and perhaps social accountability could help. So the idea was group the users together to hit a joint goal for a reward. And MVPs here occurs weekly and lasts about 48 hours. And it was introduced in session and card and lives. It's called, now I forgot what the FAB stands, with a timer. And the logic of the cohort has been to automatically group users after completing the session and randomly put them in different groups, 10 people in each group. Boost the XP, which is a metric that appears in the app for those of you who are familiar with that, or you get hearts, which again are another, it's a very well-known metric in the app for learning. And you get the gems for top 3 winners. Of course, everything here as a reward is an example of the gamified approach to learning. The inspiration for this has been from another game called Gardenscape. So the hypotheses have been that being part of a group challenge encourages the user to return to the app. The expected outcomes, metrics and analytics are that time spent learning increases, retention rate increases. Experiment setup has been for the Android platform. All countries, including Plus users. Plus users are those who will take the app, the paid version of the app, which means that you don't get to see any ads. So that's the main difference between the Plus and the free app. And the experiment arms, so this is a terminology used in computer science, comes from arms of bandits, which has to do with build a recommender system. So how you classify a particular participant in this case. So the experiments in the arms in this case are control and experiment. Now, these are the dependent, the variables, and I separated them to get back to what I started talking earlier about individual variables and then the interdependent variables that might tell us a little bit about this degree of interaction. Now, obviously, we do not have a lot of interaction in this case, with the exception of these elements here. So some chats, some profile shows appear here. Now, we also introduced a calm framework, and actually I thought I had the original slide in my slides. It looks like last night when I did the last revision, I took this off. So with my colleagues previously, we introduced this calm framework for collaborative XP. And the idea was to outline in a framework what actually happens when people work together. So you have multiple learners that are assigned to a team, and you have various learning and measurement performances here, analytics, and then you have eventually different algorithms that will either select the next task or will evaluate the team performance. And we have a considerably, we might have a dynamic team interaction methodology here as well. And we will put in a database all of these features. So this was an abstract framework, if you want, that my colleagues, Pravin Chopadi, Michael Yudelson, Benjamin Donovich, and I put together a few years ago. So now what I tried to do was to look at the CPS in the Duolingo context from this perspective. And of course, we do not have any modeling of the team performance. We also don't really have direct collaboration and interaction among the team members. In principle, this exists. So the Duolingo team has very specific metrics, and they are always visualized and reported for the regular performance and for specific MVPs like this one. So I learned from my colleagues that all the preliminary results were positive on this first challenge. They are called challenges. So we talk about MVPs, but here they are called challenges. And they were all positive on all metrics. The total time spent learning went up, the followers went up, the profile shows went up, and the retention rate also increased with positive effect size. So I learned another word here. It is kill it to iterate. So what that means is this challenge has been killed. However, a lot of good lessons have been taken away, and now a new challenge is being designed, which is, again, quite an interesting way of approaching product development, really, really fast, using the data, making decision, and moving along. So in this new challenge, I know that also direct interactions for collaborative learning are being considered. And of course, I can't stop thinking about which of the models may be most appropriate for this data. And at the moment, in abstraction of the data, I think the AFM for teams could be very helpful, because even so, there could be relatively, the degree of interdependence could be lower than, say, in a game. So in summary, revised new extension, a framework for identifying evidence has been presented. I talk about game design and framework that allow for the development of valid construct, valid measurement of constructs. And I gave a brief description of a challenge that I discovered in the past few weeks at Duolingo. And the future work is to obtain some of this data, both from the old challenge, but also the new challenge, and refine and adapt the COUNT framework and identify which of the learning models would be appropriate for that. So I want to acknowledge two teams, the Duolingo team, and also my previous collaborators that I mentioned before. Thank you.
Okay, thank you, Alina. And for everyone, because of the time, we are going to hold all the questions and answers to the discussion session. So now let's move to Professor Art Brazer's presentation. Art?
All righty, and I'll try to make up some time. My goal is to talk about collaborative problem solving and assessments of PISA, the Program for International Student Assessment that was held in 2015. And trying to advance here. As you know, OECD has these international assessments, PISA for 15-year-olds, in many countries. In the countries where I'm going to be talking about, it's 52 countries. And so, I was happy enough to serve as chair, along with Peter Foltz, on collaborative problem solving 2015. And each country has about 1,500 test takers. I'd encourage you to read the framework paper in 2013, because it gives you the theoretical framework in addition to the assessment framework. And they're very different. A lot of people get confused that our assessment framework is the same as the theoretical framework. Not true. If you look at the theory, it covers like ACT 21S, Harry O'Neill's sort of models. It has an appendix with all this background, and it has a very broad framework. However, what you have to do is do the assessment. And that's a you can think of it as a simplified version. And you can see the results in OECD's 2017 report. General points, countries are the data points to explain, not individuals. And the articulated goal is to track scores of particular countries over time, not comparing countries, but that's nonsense. Everybody likes to compare countries. And the big questions is whether increases in investments in education may result on better competencies, happiness, and income of the people in the country. I also want to mention there's also survey questionnaires that survey the 15-year-olds' parents and also teachers, and that, you know, a broader sort of psychological attributes. Now, the definition of collaborative problem solving is here. I'm not going to read through the whole thing, but the key thing is there's two or more agents that, these computer agents that interact with a particular learner. And so what you can do with these agents is stage situations, sometimes conflicts, sometimes disagreements, alternative perspectives, and they interact with the learner and exhibit characteristics of collaborative problem solving. So the assessment framework built on problem solving, the individual problem solving skills of PISA 2012. In that one, you had the standard, and this is kind of a standard model of problem solving, where you first explore and try to understand the problem, and then you try to represent the problem in some way to formulate goals. You have planning and executing the solution, and then you monitor progress and reflect on it. So that's kind of, you can think of the problem solving dimension. There's also the collaborative dimension. And this is where you try to establish and maintain a shared understanding and take appropriate actions to solve the problem, and you maintain the organization. You know, sometimes you have to regroup and reorganize in the face of obstacles. So you can think of these two dimensions. You have the collaboration dimension, and then you have this problem solving dimension. And this leaves you with 12 cells. And when you set up the scenarios for collaborative problem solving, you need to cover all of these 12 cells. So that's kind of the assessment framework to make sure that the set of problems will cover the important dimensions of collaborative problem solving that were articulated in the framework paper. This is just a concrete example. It's an example about people, visitors from out of town, and high school students have to entertain them. And so you have here, they can decide whether to go to a museum or a market or an electric car factory, and they have to figure that out. You have these agents, you, the test taker, and George, Rachel, and Brad. And this is the chat history. So in the left banner is the chat one. It's the chat activity. And, you know, in a chat, it gives you alternatives in a multiple choice. So imagine as you interact with these agents, you have a series of multiple choice conversations or multiple choice in the activity area, one or the other. Either actions you perform in the activity or chat alternatives, but they're fixed alternatives. There's usually between 2 and 6 alternatives to select from. And there you can plug into some of the standard psychometrics that we all know and love on test construction. There's also a notepad up there where you can keep it, that reflects stages in the problem solving. And one other point is the items are scaled, and you specify which of these cells, these 12 cells, an observation is when they perform an action. And when you consider all the actions in a scenario, you want to cover the 12 cells. You can add a lot of complexity. So here you have the agents. There's time constraints often, and you have to have a path between these places and worry about how much time between places. There's different vehicles of transportation. All of these need to be decided in this collaborative problem-solving environment. And this reflects the state in the notepad. And once again, you have this chat and a restricted number of multiple choice alternatives. And the developers at ETS were very clever in setting up the alternatives in a way that's meaningful to get at the essence of collaborative problem solving. There's also attitudinal constructs like we have here. Okay, I'm not going to get into any more of the details here because of time, but the one thing I want to say is we couldn't handle natural language input because it's 52 countries with many and more languages than the 52 countries. And so it was all clicks and alternatives in the action area or alternatives selections from the chat area. So here's the 4 levels that emerged. And 0 level is you're not proficient. And then you have level 1 where you have low complexity. You can't handle tough problems, and limited. You only collaborate when prompted, basically. You don't take the initiative. All the way to level 4, where there's high problem complexity, and you take the leadership to overcome obstacles and disagreements. So it's not like you're paralyzed when there's a disagreement or an obstacle. You take the initiative to handle these critical social interaction problems as well as complexities of the problem itself. So this is just a couple of findings. Here you have the different countries, and for those who are interested, this is where US, I don't mean to be country specific, but US does pretty well. One of the interesting findings is girls outperform boys in all countries. So isn't that interesting? Something to think about. Whereas boys in individual problem solving slightly, minusculely outperform girls in individual problem solving. So something to think about. You do have the predictive validity does correlate with individual problem solving, so they are related, but there is an incremental gain in the collaboration per se. It's not entirely redundant with individual problem solving. This is one of my favorite slides in training kids how to do collaborative problem solving. It's certain activities contribute. So you have in the light blue bar before accounting for gender and socioeconomic status. You find being in a band or an orchestra or being in a musical or on a yearbook or newspaper magazine or volunteering for service or sports. These activities contribute to and predict your performance on collaborative problem solving. So what's happened since then? One thing is there's been a lot of critiques. And part of these critiques is people confuse the framework with the assessment. That confusion happens all the time. And you can't assess everything. It's impossible. So, but one question is how similar is this with interaction with agents to human interaction? That's been a big question. Negotiation is missing in PISA 2015. It's actually there, but it's a very degenerate form of negotiation. It's like one person says something and then you may disagree with it. It's not the back and forth in many terms. What about the role of personality? We were told to leave emotions and personality out of the assessment. That came from the top, out of the OECD. Our goal was to focus on cognitive. So there's been a lot of empirical studies and critiques. We tried to create a report. We wrote a report for NAEP for assessment in schools, and many of us put a lot of hard work in, and I don't know where that went. Interesting question. Lots of edited books, and you know, that's what many people do. They create print. And so here's, in the military, they have a deep interest in collaborative problem solving. And so they're talking about intelligent tutoring systems of teams. So the military is a group, since the unit is often a group in military settings. They want to train them and have different training methods for it. So it's actually the military that in many ways are taking the lead in the cutting edge research on this. I think Pat has a grant with the Army on this. And of course, there's journal articles. Two of my favorite are these. You know, you can read about it. Some empirical results have appeared in this special issue of Computers and Human Behavior. One point is no differences between interaction with agents and humans. In tasks where it's not completely open-ended, it's where humans choose among options, a fixed number of options still, but comparing what the agents did and substituting the human for an agent. And think of it as substituting either the agent or human in a very local interaction, not the complete macro interaction, but very local. There's been also all sorts of log file analyses of didactic chat, we're in the middle of trying to discover tactics for successful negotiation, because PISA 2015, it didn't really represent the full suite of negotiation tactics. And then there's all these analyses of open-ended natural language. And some of it is by data mining and machine learning. Others is more top-down through evidence-centered design. And so the last point I want to make is a widely accepted CPS framework has really not replaced PISA 2015. I mean, people have tried little pockets of things, but I still think it is a place to go to. The framework, the full theory, not just the assessment, is something to go back to and revisit from time to time. Thank you.
Okay, thank you, Art. This is a great talk. And now let's move to Nancy. So Nancy, you're muted. We cannot hear you.
Yes, I'm very sorry. Okay, so I was just saying that it's good evening here for me and good morning for most of you. Well, first of all, I have to declare that unlike all my other co-presenters, I'm actually not a psychometrician. I'm not from the education measurement area. And my interest in assessing CPS is actually born from my interest as a member of the, what we call it, computer supported collaborative learning community. So And the work, we have actually done a little bit of work on assessing CPS. And the interest in that is because we have a reasonably big project on learning and assessment for digital citizenship. And actually the empirical work that I'm presenting here is very much the work of a joint effort, and particularly led by my PhD student, Haley Zhang. And also we have a game on online collaborative game, and is developed by colleagues at the University of Science and Technology. So for us, the reason why we're interested in CPS, as I said, is that we're interested in digital citizenship as the competence and the rights and responsibility to engage and participate in a globally connected world. And so human learning or human capacity is important, and at the core of it is the metacognitive and cognitive capacity for digital literacy and collaborative problem solving. And so here is a quote about CSCL, and it's a field of study which is centrally concerned with meaning and the practices of meaning making in the context of joint activity. So it's a joint activity, and it's the ways in which these practices are mediated through designed artifacts. So I don't need to talk about it. So this is the CSCL, the ATC21S CPS framework, and so it measures. So the way it measures is try to assign tasks for or scores for these different parts of the framework, and for the PISA is different. So we heard it already. And what is interesting, of course, there are some differences. So, of course, one is the human to human, and the other is human to agent. And then I see that the ATC21S, the collaboration model, is very much a jigsaw model, whereas the PISA CPS is very much a kind of like a decision tree to see how the students sort of go down the decision tree. But there are also similarities between the two systems in that CPS is, and I mean, for both, they are really assessing CPS as an individual attribute or capacity. And so as in any educational measurement, the ideal is that you are assessing something which is relatively stable, is context independent. And when we talk about context, it's probably task, social, and technological. So that's the ideal, but at least you're trying to get to something which is relatively stable. But for those of us in the learning sciences, then we look at CSCL as a pedagogical approach where learning is fundamentally social. And so you have peer interactions and discourse around artifacts and tasks. And so for us in CSCL, the focus is not that much on the, of course it's a process, but we are focusing on the learning, and we're focusing on, so rather than looking at it as an outcome, we're looking at it as looking at it for learning, and then the learning is the knowledge and the skills, and also knowledge building or knowledge creation. And so for assessment practices, we are focusing more on the outcome of the collaboration. And also, of course, the understanding of the individual. So what we did was, I mean, because we are interested in, we do see that the value of collaborative problem solving as a human capacity. So in one sense, it makes perfect sense to assess. But then how do we assess it? And does it, I mean, so what are the, I mean, how similar or different are we thinking about in terms of the capacity, the human capacity of CPS? So we, I mean, as PISA CPS, we can't access the system, but then we were able to license the ATC21S collaborative problem solving system for part of our research. And we also have we're still in the process of developing an online role play game where we can have more members than 2, and we can also go to younger students, because I think both the CPS and the ATC 21S, they are, well, I think ATC 21S is able to target younger students from age 11 onwards, but there's nothing below that. And we try to look for things which we can use to assess CPS for younger children. And we also try to compare the assessment. So for the online game, it's basically a serious game where the students are trying to help people who encounter cyberbullying situations and trying to identify the problem and help them out. Okay, so this is what my students' work has been very much working on. So the idea, so she actually did several studies, and in the process we are trying to look at how the CPS, if we're actually using the ATC 21S assessment framework for the coding, and she did a lot of basically she was doing case studies and in-depth qualitative analysis. So the 3 studies are like this. So the first one is actually fully open. It's very much in, aligned with the sort of CSCL type of situation, but here we are focusing on the process. And so the students were coming in over 3 consecutive Friday mornings, and they work in groups of 4, and we have mixed ages from 8 to 13. And there were 2 groups with children that are 11 years and older, and we administered the ATC 21S CPS system. The second one was more open-ended with structured task, and we have the students only there for 1 half day, and they have 1/2 hour on the anti-cyberbullying game, and then the second task is to improve the game design on the storyboard. And the first study I'm not going to talk about. Let's talk about this, the study 2 first. So in the study 2, as I said, they were working on playing the game first, and then they try to improve it, and they try to draw on the storyboard for the improvement. So with this, the question we try to answer is, will there be discrepancies in the CPS scores for the same students in the 2 task settings? And let's look at the, say, 2 of the groups. If you look at, say, group, so we have the group A and group B, and you have the cognitive skills and the social skills. And if we look at both groups, it's quite clear that in both cases, the cognitive skills exhibited during the game design is much higher than the cognitive skills when they were doing gameplay. And the other way around for the social skills. So of course, I mean, one can also ask, how important or significant is the social? I mean, does it mean that you have a higher score than they're really better? It's not very clear. But and so we have 2 questions. One is less structured task design, say like the game design, would provide more opportunities for exercise of cognitive skills? And what about social skills? Is it true that gameplay would be better for developing social process skills? We are not sure. And then if we look at, and then coming back to the study 1, they were working for a more extended period of time, and it's all on sort of a very open-ended game design task. So we want to look at CPS behavior change over time and look at group dynamics, and also compare the CPS scores of the individuals assessed through the game design task and the ATC 21S system. So if we look at, say, Group A, we look at workshop 2 and workshop 3 because workshop 1 was just warming up, so there wasn't much happening. And then we were interested in looking over time. And you have 4 students here, GD 28 to GD 31. And if you look at the cognitive skills in workshop 1, then it's quite clear that number 28 is much higher. But if you look at the next workshop, then it changes tremendously, and 31 becomes much higher. If you look at the social skills, then again, there is a change. But what is also quite interesting is, if we look at the ATC 21 as cognitive score, then 31 has the highest cognitive score and social score. So what does it mean? Well, in some sense, we were quite, okay, so we were observing those numbers, but we're also observing, how the process pan out. So we're looking, so these scores were done by analyzing the video, the discourse, and so on. But then if we look at the persons and the process, actually 28, now very interestingly, at the end of the whole thing, we interviewed the students. And then we asked, one of the questions the students were asked was, if you were to do all this all over again, what would you do differently? And you know what they said? We want 28 back. She is our leader. We want her back. So basically 28 was, she's a girl, and she's also very much sort of co-regulating and regulating the others. So, and 31 was the one who started with not really caring about others, and it was very on task. But anyway, so in this sense, what we were a little bit, so what we've been thinking about in this case, I said, so group two, you have quite an imbalance across the students, and they seem to be more stable across the 2 sessions, but at the same time, they were, this group was relatively much lower in terms of both in both the cognitive and the social score according to the ATC 21S system. But at the same time, if you look at the group scores, you can see that the social score is much higher compared to group A. So I think, because I don't want to go, because I know we're running out of time, I just very quickly want to sort of go to the end. We actually not only do the small groups, we were actually using the system to assess, I think, a secondary 1 cohort, which, and also a secondary 3 cohort. So one is about 12 years old, and the other is 14 years old, and yes, and each about 800 students in each. And we see that now, so because we were using the instrument from ATC 21S, so we were able to compare our student score with the reference sort of population score. And we have rather poor cognitive skills and relatively high social skills. And if we look at the whole population, then our students, so we have the comparison of each of the schools for the 2 sets of process skills. And we see a lot of inter-school and intra-school differences. And what is also very interesting is that we see that the digital literacy score, because we develop our own digital literacy assessment, it correlates rather highly with the cognitive CPS score, and not so much with the social CPS score. So what are we left with? So at this point in time, we are struggling with two questions. The first is, what do these various scores resulting from the analysis of the student's behavior actually tell us? And what do we really wish to measure through CPS assessment, and why? So I think with this, I better stop. Thank you.
Thank you, Nancy. The very great introduction of the wonderful work you are doing and your team. So now let's move to my talk. And so I'm going to introduce some of the work we are doing at Educational Tasking Service. So ETS was deeply involved in the CPS assessment of PISA 2015. And then around 2012, we started a new round of R&D efforts in 4 main areas. So this new round of effort was initiated by our second presenter, Alina, when she was with ETS. And the 4 areas are identify and develop constructs for scalable assessments. So a core theme of our work is more on scalability. So we want to create some kind of assessment that can be done at a scale. And the second area is to develop the technological infrastructure and data analytics system. Everyone work on the CPS know that it's so difficult to set up the task and collect data, and we're trying to make this piece solve the issue so that we can easily scale up the study. And then we develop assessment prototypes and collect empirical data to do actual study. And also another important piece is we develop some psychometric toolkits, such as the scoring strategies, how we should score things, and the modeling strategies, and some trying to establish some of this psychometric quality benchmark, so how well we can measure things. So we have a paper that have a lot more details about these 4 areas, and if you are interested in, you can check this out after this presentation. So far, we have developed over 15 assessment prototypes and collect data from over 2,000 teams. So this is a growing number, and I think by the end of this year, we will have 2,500 to 3,000 teams of data. So there's a lot of funded research within ETS and done by ETS colleagues. And here I just show you a brief screenshot of all these projects. So each of the row is a project led by different people. And this is funded by ETS internal research allocation. And also we have several projects funded by external funding agencies such as IES, NAEP, Army Research Institute, and even foreign collaborators. So the reason we can do so many studies in such a short period of time is because we have a pivotal software infrastructure. So this is just to make the data collection and the task development a lot more easier. So let me try to give a brief summary about our approaches. And basically, we build our work on top, on the shoulder of the 2 giants, ATC 21st and PISA 2015. And we focus on the human-human collaboration while internet-based platform. So for the task design, it's really about what kind of task we need to use. We consider several factors, such as the symmetric versus asymmetric roles, whether the team member, they are playing the same role in the task, or whether the team member possesses the same amount of information, that's symmetric, asymmetric information, or sometimes called jigsaw of hidden profile if different people in the team say different information. And their communication is through chat and video, audio-based communication. Then for the assessment design, it's really, we realize it's really driven by the way you're trying to report the score. So there are different interests in terms of the score. For example, sometimes you want to know the individual performance, individual score. And in that case, you cannot have a single student play a task, a game, a collaboration. That's not sufficient. You got to have this kind of round robin like design. Basically, one person work with other collaborators in multiple teams so that you can average out the partner dependency. And then if you want to report the group score basically answers the question like a student in New Jersey is more collaborative than a student in Pennsylvania. For example, I just make up this. Basically, you don't care about individual performance, but more you looking for the collective information. And then you can have some kind of a random team assembly. And meanwhile, we realize that just measure the collaborative task is not enough. You also need to have some measure of their related relevant competency at the individual level so that you can stitch everything together. And another important piece we found is the facilitation. If you ask people to work together without any facilitation, that's usually not going very well. So we implement some kind of facilitation, either hardwired or through some intelligent real-time feedback. I will talk about this a little bit more detailed shortly. And then it's about the source of evidence. There's the communications, actions, and the responses. From the talk by Esther and Art, the ATC 21st and PISA 2015, they all kind of do not focus much on the communication data. And we realize that this can be a critical piece in understanding the collaboration. So we put this as a major piece of our work. Then for the scoring strategy, clearly there's a collaboration process, there's a collaboration outcomes, and also there's a relationship between the process and the outcomes. We think that only when you jointly consider the three factors, you can have a more holistic reporting of the CPS performance. And then there's a different psychometric modeling schemes and the specific statistical models. So let me talk a little bit more about this AppCal ecosystem. That's our core software infrastructure. AppCal is the acronym of ETS platform for collaborative assessment and learning. There are 6 key features like a real-time multi-model communication and the management of participant and team formation and task item management, task progress control. I think this is a very important feature because when people work together, you want them to be synchronized to some levels rather than one person just to start, another person already at the end. So the platform does allow us to control this progress. And then we have some AI-driven facilitation and scaffolding. And last but not least, we have this integrated data analytics system to make the data analysis way easier. So basically, we are opening this platform to the research community for collaboration. If you are trying to write a proposal or trying to do your own study, and we are happy to work with you to provide this platform to help your work. So the facilitation of the collaboration flow, we consider 2 types of facilitation. One is a hardwired facilitation. That basically means we make the collaboration following specific procedure. For example, we ask students to respond to the question individually first without collaboration. And then we ask them to collaborate. And then we ask them to submit a revised answer. And all these are hardwired structure of the collaboration. On the other hand, there's we call intelligent facilitation. So basically based on the response or the communication, we have a NLP-powered web service to to check those things and give them feedback based on certain rules. For example, if someone blurbs some dirty words, you do not want that to continue, and you can just send them a note. And then, as I said, the communication data is one of the core things we consider, and therefore we need to have some kind of infrastructure to make the annotation of the communication data easier. So we developed a human annotation system. So I think if many people, they probably still annotate data using the Excel spreadsheet. And we realize that's highly inefficient and it's not scalable. And we developed a nicer interface to annotate the communication. And at the same time, we built this so-called CPS reader, is an AI-based automated annotation system. So when we have enough training data from human annotated data, we can run this automated one to do the automated annotation. And then we have this integrated data, all this data from this collaboration task, their communications are structured into a very well-designed data model. And then we have an analytics pipeline to analyze data and visualize and perform different modeling. So give you a sense of the different prototypes we developed. The first one here is in the domain of science. It's in the English language art. It's in the decision making. It's in the negotiation, and it's the engineering design. And this last one is open like a physics lab. And this is a new interface we developed for this app called system. So now let me talk a bit about this scoring and reporting. So we developed this, as I mentioned earlier, this scoring strategy. Basically, we developed this scoring strategy. There's three components. There's a collaboration outcome-based measure, such as the problem solved or not solved. And then we have the collaboration process-based representations. For example, this can be the features based on the annotated communication, different skill categories, their frequencies, their interdependencies. And then we have this feature based on linguistic feature of the communication content, like a sentiment, a word use, all this kind of NLP features. And then we have the feature based on the amount of interactivity and the timing, how long how frequent people communicate, how long one person wait before he or she respond to the partner, this kind of information. So this set of the informations, they are used to represent the collaboration process. So then when you have this process and outcome, the very important piece is to see the relationship between the process and outcome. And here, let me show you an example of a report, the kind of group level scores. For example, if you want to report the collaboration outcomes, you can say students do better in teams than individuals. Right? All students with certain partners will gain more from the collaboration. These are all possible ways you report the outcomes. And if you want to report this collaboration process, like students show more one type of like negotiation skill, then sharing idea skill, this kind of thing you can report. And if you want to report the relationship between the process and the outcome, you can say, oh, teams show more negotiation skill lead to better outcome. Right? All these kind of things can be varied by different subgroups or demographic groups. So here is an example from our actual study, empirical study, aligned with the previous three scoring components, like outcome. We found people working teams, they do better, way better than when they do individually. And here, this one is basically say, this is score change. After collaboration, everyone, no matter who you collaborate, there's a score change improvement. However, if you are collaborating with someone with a higher skill than you gain most. So for the collaboration process, you can see the profile of the percentage of different, here we consider 4 collaboration skill, maintaining, regulating, negotiating, and sharing. So you can see different profile of the different people, different students, how they change when the task change. And then for the relationship between process and outcome, and here you can see the green dots, they are the team, they have a more positive collaboration outcome. That means their performance improved after collaboration. And you can see the x-axis are the collaboration process skills. So the negotiation skill makes a major difference. And this can be feedback to like teaching, say, oh, you need to negotiate more if you want to get more positive collaboration outcomes. So here is a psychometric quality benchmark, and this is based on the inter-rater agreement. It's a pretty decent agreement. And then this is based on the correlation of two parallel tasks. And you can see we have so many different categories of the CPI skills, but when they do the parallel task, their correlation is pretty decent. So right now we are working on a project funded by the Army Research Institute, led by my colleague Pat Kalani. And we are examining individual contribution to the teamwork through a complex assessment design. Meanwhile, we are moving all the effort to this classroom-based collaborative learning and assessment, so the teacher can arrange. You can think in a whole semester, teacher, every a few weeks, you can have this online collaboration activity, and teacher can arrange team members. And then all these students' behavior activities is finally aggregated into a teacher dashboard. By the end of the semester, the teacher can see, oh, which students do better, to what way, and they can give them more tailored feedback. So I think distance learning these days make this a great opportunity for us to do this kind of research. So let me wrap up this acknowledgement, and just want to emphasize that we are open to collaboration with external researchers. If you are interested in collaborating with us, please send me an email. Here is the references. So thank you very much, and my part is done. Let me give my desktop to Pat.
Okay, I have 2 minutes. Thank you. So given that I only have 2 minutes, I'll just try to wrap up a couple big messages here. I'm not gonna, I have an 10 slide presentation here, but I obviously won't be able to get through that. If you'd like to see the presentation, please feel free to email me. I'll be glad to share it. A couple big messages. One is that there's every reason to believe that the kinds of skills that were represented by measurement systems presented here are going to grow in importance. There's good documentation for that. That's point number one. Number two, we have very, very few good tools to measure those skills, collaborative skills, social skills, negotiation skills. And so the kinds of a nice sampling of approaches that you saw here are extremely interesting as a way to get beyond the typical mode of measurement, which is teacher ratings, peer ratings, and student self-assessments. And so this gets way beyond that. The problem with the methods that we saw here today are extremely data-hungry approaches. The only way we're going to get out of this problem is by collaborating. It was a kind of a point that John Gong made at the end there. We have to figure out a strategy to get groups working together so that we can collect data jointly, and that's where the real progress is going to occur. We already have very good indications that the the final frontier is process analysis. And process analysis is very costly, very expensive, especially if it's done by hand. I think Nancy had a project, Esther knows this from her work. We have to get into automated tools for doing this. Automated tools are not useful unless you have lots of data. Google Maps is useless when there's no cars on the road. And I mean, it's, you know, if there's no one subscribing to services that contribute data. And this is where we have to get with this kind of work. So at that, my time is up, 10:30, and I think that closes the session.
Thank you, Matt. Thank you, Pat. I just talked with the conference organizer that we can have 5 more minutes to address any questions from the audience. So if you have any questions for each of the presenters or discussions, please just let us know. Let's just wait 1 minute, and if nobody have questions, and we will conclude this session. Oh, there's one. So thank you everyone to come to this session, and we kind of put too many talks in this session, and it's too much information for you to digest. I think the organizer recorded the video, and if you are having additional questions, please feel free to contact us. And I hope everyone has a great and safe the rest of the week. We have